Welcome to Study Loop.
So when I first started reading this question, it appeared that it wanted me to calculate the chloride concentration as pretty much all the information that is required to calculate the chloride concentration is provided, but the question specifically just wants the balanced equation for the overall reaction. Well, the overall reaction is going to be, for a galvanic cell, the half reaction that wants to be reduced the most being reduced, the other half reaction being reversed, serving as the anode. So the half reaction that wants to be reduced the most is the copper 2+, so Cu2+, plus 2 electrons goes to Cu solid. That occurs as is, where E standard is provided at 0.337. The other half reaction is Ag solid, or AgCl solid, plus 1 electron goes to Ag solid, plus chloride. And this one is not quite as large at 0.2223 volts. So this one will be reversed and serve as the anode. So the overall reaction, after we multiply this one by 2, is going to be Cu 2+ plus AgCl solid, 2 of them, goes to 2 Ag solid plus 2 Cl minus aqueous and Cu solid, and the E cell standard will be equal to the cathode 0.337 minus the anode 0.2223, giving us a value of 0.1147. So if we were asked to calculate the chloride concentration, we'd use the Nernst equation. E cell, this will be the measured potential, which they've given to us at 0.0623, will be equal to the standard potential, 0.1147, that we just calculated, minus at 25 degrees Celsius, 0.05916, divided by the 2 electrons that are transferred, the log of Q. Q is going to be the concentration of chloride squared, because it's a product. The 2 solids are excluded, divided by this solid that's excluded, and just the concentration of copper, which they tell us is 0.500. And so they didn't ask us to calculate chloride, but they gave us everything we needed to calculate chloride, and we just solve this equation to get our chloride concentration. I hope that helps.